I don't know. It's easy and hard, the right words, I don't know. Different. It's different. Shall we look at the answers now?
No, we didn't do 6.
Well, there's not much time left, so we'll do the answers together. If you want, I can leave 5 and 6 for you to do at home, and I'll do 1, 2, 3, 4 now.
No, you can do 6. Here.
No.
We did together one, you know.
Oh, let me see how I feel.
No.
No?
Yeah. You helped us until 5.
You did really?
Yeah.
I mean,
Okay.
it's not like we did it.
But I'll just write the answers down, so for the 2 people who aren't here.
Okay,
Yeah. Because the reason I record it too is for people who miss it. So the first one is the units of PV, and the units P is newtons per meter squared, and V is meters cubed. So that's Newton meters, which is the same as a joule. So the dimension, well, rather I said dimension, but whatever, units is joules. 2. So the plane is flying. And we saw earlier that the atmosphere is 10,000 meters, and here's the plane here, and it's at 10,000 feet. Oh, sorry, I drew that backwards, and it's at 10,000 feet. So we actually just want this distance. That h is 10,000, and I said 3 feet is a meter, so minus 10,000 over 3. Which would be 6,667 meters is the h. So the pressure, the formula is rho g h. That's roughly 1 times 9.81 times 6667. So if I go to my calculator, 9.81 times 6667, and I'll make it kilo. 65.4 kilopascals. By the way, let me see how much of an atmosphere that is. What did I say an atmosphere was? 101.35, wasn't it? Wasn't it?
Yes.
It's by the answer,
yeah, so it's 0.65 of an atmosphere. So think about what I'm saying. On the surface, we have 1 atmosphere of pressure. In the plane, we have 0.65 atmospheres. So the plane is required to pressurize the cabin so that the people inside it still feel the same pressure as they would on ground level. So you've seen this in movies before. What happens when the door breaks open on the plane in flight? It pulls people out. Because the inside of the plane is at 1 atmosphere and the outside is at 0.65 atmosphere, so the pressure, the air rushes out to the lower pressure. This is what's happening. Yeah. So pressure, it tries to go from high to low, just like heat will go from hot to cold and so on. So 0.65 of an atmosphere. The key reason, as you said, the density is not small, is the key reason for why the law doesn't work. 4, the way you did it was fine, but I was hoping you would spot the easy or the quick way to do it. How tall is the building? 100 meters. So I want to know which pressure will be bigger, P1 or P2? Yeah, P2. So I want to know the difference in the pressure, which will be P2 minus P1, which will be rho G H1 minus rho G H2, which will be rho G H1 minus H2, which is rho G delta H. In other words, if this is H1 and this is H2, the difference is the height of the building. So it was about 1 times 9.81 times 100, which is about 981 pascals. Do you get the same answer? Yeah, but longer, right? Yeah. Now, that is enough to be measured. So if you had a barometer measures the pressure of the air, a digital barometer perhaps, and if you stand at the ground level and look at the pressure, and then go up 100 meters and look at the pressure now, it will be different by 981 pascals, which is nearly 1 kilopascal. So on the ground level, you'll have 101.35 pascals, and when you travel up to the top level, it will only be 100.35 pascals. That is easily measured by a barometer. You'll definitely notice that difference. Yeah. In fact, these digital barometers are so accurate that it could measure a difference in pressure for only 1 meter of height.
Kilopascals, right?
Yes, thank you, sorry, kilopascals. There are some mobile phones that have built-in barometers, and they're accurate enough to measure pressure differences on a meter level. Which is pretty sensitive if you think about it. I know this because it's sometimes used by some apps to work out your height, how high you've climbed a mountain. You know, it will look at how the pressure is decreasing. So for example, if you take out your app and you say, I'm on ground level, start, and the app sees that your pressure decreases to this number, then it knows you've climbed 100 meters. So this is how these altitude apps work. Yeah? Interesting, I think.
Yes.
Interesting. Right, now what's the story? You want me to do 5 or you don't? Ah yeah, we'll do 5. Might as well. We've got time, haven't we? Yeah, we'll do 5.
Alright.
We've got time to do 5. Right, so 5, what's the energy? So you know the formula is PV equals 2 over 3E. So that means E equals 3 over 2 PV, which is 3 over 2 P 4 over 3 pi r cubed, which is 3 over 2 times 101.35 times 1,000 for kilo times 4 over 3 times pi times 0.3 cubed. Okay, calculator time. Problem?
Please ask why you take all of it.
Is it?
Yeah, thank you.
Oh, so sorry. Thank you for spotting that. Over 2. So 3 over 2 times 101.35 times 1,000 times 4 over 3 times pi times 0.15 cubed, 2,149 joules of kinetic energy in the balloon because of the movement of the molecules.
Is it too big?
Huh?
Is it too big?
About 2.15 kilojoules. Is it too big? I don't think it's too big. Now, you realise that's the kinetic energy of all the moving air molecules in the balloon. Now, actually, what is air mostly made of?
Oxygen and oxygen.
Yes, which is the dominant, nitrogen. So, if you knew the mass of the nitrogen, and if you knew how many molecules are in the balloon, you could work out the velocity of each molecule on average. Because you've done the ideal gas law with Lorraine.
No.
Ah, you have.
No.
PV equals nRT.
Is it the ideal gas?
It is the ideal gas law. So you've done this one?
Yeah.
So you could use this to work out the number of moles, true? And from the number of moles you can get the number of nitrogen atoms. If you know the mass of nitrogen, which you can know from the periodic table, and if you know how many nitrogen atoms you have because of your formula, and you know the total kinetic energy, by dividing the total kinetic energy by the total number of atoms, you could have the energy per nitrogen atom, And if you knew the mass of the nitrogen atom, you would have the velocity. So that's something we'll have a look at later. Yeah. Now let's deal with number 6. You know, I'm going to let you try it at home, because you've done 1 to 5 yourself, and I believe in you. I believe you can get number 6, because I'll give you a little hint of number 6. It really comes down to just using that formula PV equals 2 over 3E. This will be the key.
What is the volume of cylinder?
Pi r squared H. You learned these in middle school, didn't you? You don't do these in Sudan? No. Right.
Is you?
No, if he didn't do it in that, I definitely didn't do it in that area.
No? You don't remember these formulas?
But this will be given in the
It will not actually.
actually will not.
Yes. The physics formula book only contains physics formulas, no maths formulas. That includes, you know, area, volume, quadratic equations. It's only physics formulas and constants, no mathematical formulas or constants.
In the exam, if you have that,